Okay, thank you, Alej, and thank you for all the data science groups that have organized this webinar today. I'm going to share my screen now, and this will be my talk. I plan to talk for about 20 to 25 minutes, and maybe then in the questions and answers we can go back to points that you may want me to explain with a little bit more detail. So the questions that we are going to address today is what can we get from the telematics data that we collect from drivers, and can we really identify risky drivers, and can we do something about them? So the talk is organized in those 7 parts, but essentially today I want to start by giving you an overview of what is telematics data. And here in this slide, you can see that there are many types of telematics devices, but all of them collect information on individual vehicles. This information comes as data streams that provides hundreds of variables. One of the most important variables is the distance driven. So you can get information about how many kilometers, meters. You can also get the position, but usually the exact position of the car is deleted from the telematics data stream for privacy reasons. However, average speed, time of driving, the zone, and many other indicators are collected from these sources. Using this information and combining this information with accident data, insurance companies can create what is known as the UBI. This is known as the usage-based insurance. And there are 3 types of usage-based insurance. The first one is pay-as-you-drive, meaning that you pay per kilometer. So if you drive 1 kilometer, you have one price. If you drive 2 kilometers, you pay more, and 3 kilometers you pay more. There's also another way of doing this, that's pay how you drive, where you take into account how people drive. I mean, if the speed is too high, then probably the price will change. And there's a third way of doing UBI, and that's called manage how you drive, meaning that you give information back to the drivers. So essentially, these are the 3 topics that I'm going to address today. But before doing that, I'm going to show you how a summary of the telematics data look like. And this is, for example, a summary of one driver, where you record the starting date and the starting time, and then you record how many kilometers or meters the person has driven in urban area, how many seconds, then the car stops. But this is already a summary. So as you can expect, this comes from raw data files, and it's quite complex to decide what are the relevant summaries to be made. Another thing that I want to stress here, and I'm not talking about rocket science, I'm just talking about real things. Insurance companies are really selling this kind of insurance, and we can really buy telematics insurance around the world. Here you have 4 examples. The first one is Metromile. This is a company based in California, where if we own a car in California, we can go to Metromile and we can pay by kilometers. So we will have a fixed cost and then a cost depending on how much we drive during the month. Similar product, we can find it in the UK, and it's by miles. There are other companies. You can also buy it in Generali, in Spain. Verti, it's a company that has been doing this for longer. Okay, so what are the questions that I want to address in today's talk? The first question is, how should this pay-as-you-drive insurance schemes be designed? Are they correctly designed? Because they are being sold, and we can really go and buy one of those types of insurance. Okay, are they designed correctly? The second question is, how can near-miss telematics be used to identify risky drivers? And this is important because we introduce a new concept called near-miss, and I'm going to define what it means, and I'm going to show you the advantage of using near miss information. And near miss, I'm just going to tell you, it's not an accident, but it's a very risky situation where there was almost an accident, and that information can be used to identify risky drivers. And the third question I want to introduce today is a little bit of new methods that we are working on today. I mean, this is the result of a very long time of working in the research group at the University of Barcelona. And this last part, where we use risk analytics and percentile charts and reference curve, is the current topic of our research. So I'm going to show you also a little bit of what we are doing now. Okay, let me start with my first part. So my first part is how pay-as-you-drive insurance schemes be designed. All right. For every question, what I have prepared for you is a summary slide. In the summary slide, I'm going to tell you what is the current market, what we can see really out there, what is the innovation that we are working on, and a little bit of flavor of what the conclusions are. So in the current market, it's true that we can buy pay-as-you-drive insurance. So in most European countries, we can go and pay a flat rate, which is a small amount of money per month, and then a fixed price per kilometer. So suddenly, many drivers in Europe are becoming very interested in this type of pay-as-you-drive insurance contract, because if we are not using the car so much, then the price is really accommodating to a situation like the pandemics, where the cars were mostly stopped at the garage. So the innovation that we have been working on in the latest years is okay. We always keep a flat rate, because no matter what, a car can be damaged, and so there will always be a flat rate. But then the price of each kilometer will depend on other factors affecting the accident risk. And here I'm giving you a very little plot, but what you can see here is distance driven over 1 year of a group of drivers. And here on the vertical axis, you see that the frequency of accidents. As you can see, this is not a linear trend. It's somehow bumping at the end, meaning that, well, there is much more heterogeneity in the frequency of accidents for those drivers that drive more kilometers per year. And here you can perhaps assume this linearity, but it's quite arguable that there is some heterogeneity here. So as a summary, what I'm telling you is, okay, the main message is the risk of having an accident is not linearly dependent on distance. So why should we really have this pay-as-you-drive insurance scheme? There is a learning effect, and we can introduce all those factors, and they make the price per kilometer change. Okay, now I'm going to overview quite fast what are the methods that we are using to discover all these findings in this context. And I'm just going to go quite fast. In the classical model, what is predicted is the number of claims, which is the number of accidents that are reported to the insurance company. And essentially what we have is we have an insurance policy holder of n insurance in the portfolio of our company. We have a vector of covariates, and the dependent variables is essentially the number of accidents that we have observed over a period of time. So we really fit the generalized linear model. This is what is done classically. And what we have done in a recent paper published in Transportation is that we have also included in this classical modeling information collected from the telematics data devices. Okay, and here you can see all the details and a way of doing as a correction of the classical rate making model. Another thing that we have also analyzed in this context is, okay, if we want to use telematics to improve insurance rates, in this paper published in Risk Analysis a couple of years ago, what we really analyzed was a very important problem in this kind of data, which is known as the excess of zeros. So if you look at the data for accidents, a lot of drivers, we don't have an accident in 1 year. I mean, that's known as the excess of zero. And the classical way to address this problem is by doing or one of the possible ways to do this is what is known as the zero inflated Poisson model. So the probability of having zero accidents is made out of two parts. One part is just the Poisson behavior, so the probability of having zero accidents in the Poisson distribution that is depending on other covariates, but there is an extra probability, and we have analyzed things that matter on this probability. So this was really analyzed in this paper. So here in this first part of what we have done, what we really have found is that, of course, there are more things to be considered than just the kilometers when you want to introduce this kind of usage-based insurance. Of course, there are many, many other questions that I'm going to skip today about the frequency of updating of these models. And later, I will also explain, okay, why we cannot use other methods or other models to address these exact questions. Let me go to the end, and then, because everyone is immediately thinking, okay, why don't you do machine learning here? I'm going to tell you why later. I mean, we can really do this, but there is a regulation problem that we will consider later on in my talk. Okay, let me now skip to the second question that I want to introduce today. And this is, okay, how can near-miss telematics be used to identify risky drivers? And this is really motivated by the fact that there are so many zeros in the data that analyzing accidents is actually analyzing a rare event, something that happens very infrequently. So this is the reason why we have created this new concept called the near miss. And the near miss is a term that is borrowed from aviation safety, and that's a situation in which an accident is narrowly avoided by an airplane. Okay, so we have just translated this concept into the regular driving context, and we have defined what we call the near misses. And for example, a brake that happens suddenly, it's not maybe an accident, may not lead to an accident, but it's a dangerous situation. Of course, we have many, many more near misses than we do have accidents. So we have now a different phenomenon that, and this phenomenon can be studied in a different way. So and then, okay, this is the summary. In the current market nowadays, no company that I know of is really looking at this. However, the researchers, we have already done this innovation, and what we propose is that instead of looking just at the accidents, we can look at the near misses, and then there's going to be a flat rate for insurance, but then the price will depend on how many observations of near misses, because we know those near misses are correlated with accidents. So people who are doing more near misses, drivers who have more near misses, will tend to have a higher risk of having an accident. Of course, we have had a lot of discussions with other groups, mainly in Europe. There are other groups in Belgium and Switzerland working with this type of problem. And actually, there is a debate about how a brake has to be, a sudden brake has to be defined. So the main message is that the insurance cost should also reflect this safe or risky driving. And here I'm just showing you a paper that was published last year in the North American Actuarial Journal, where we really introduced this concept, and we show how this risk can be predicted by using these near-miss events. In that paper, we define three types of events: acceleration event, meaning that there has been a very fast acceleration, and we have used this reference of a changing speed of 6 meters divided by a second squared. We have also defined braking event. We have also defined a cornering event. And this is what has been done in this paper. And we then model these events instead of the accidents. And okay, just very briefly, there's an ethical question here. Should all drivers be penalized equally for excessive near-miss events, regardless of the driving zone? That's very important, because if we are driving in urban areas, in cities, it's very much likely that we are breaking more than people driving in the countryside or on highways. So in some sense, we are also saying, well, maybe the penalization, the cost of near miss events is heterogeneous as well. I'm going to show you one of the recent things that we have done, and this is an example. This table one is an example of what the insurance bill could look like in the future if this near miss concept is introduced. Here you have 5 weeks from week 1 to week 5. The distance driven is increasing, but distance driven is not really introduced in the model. You have the number of near misses of the 3 types. Here we have considered brakes, acceleration, and phone use, because we consider that using the smartphone while driving is dangerous. And then there is a price to be charged for each of those brakes. And as you can see, the cost each week depends on this number of near misses. So the weekly price is calculated based on the number of near misses, and here it's brakes, acceleration, and smartphone use, and there's also a flight rate. So usually there would be 1.95 euros. Okay, I must stress something. Don't go now to the newspapers and say that insurance is going to cost 2 euros per week, because what I'm doing here is doing the actuarial price. So this is the basic price before all the extra expenses have to be added. So there's no insurance companies that can do this very, very cheap price, because they have to add more things into this pricing. But this is the skeleton of how the price is calculated. Okay, I want to highlight a couple of things. The first thing is that near misses are high frequency, and accident risk is low frequency. So we especially like this orientation of the problem, because the problem of low frequency in accidents is a very difficult problem when you start using machine learning methods, because of the rarity of the events. Okay, and then also I want to mention that we need to produce a model that is compatible with the regulation. The insurance companies are much more regulated than pharmaceuticals. People think that pharmaceuticals and drugs, vaccines nowadays, we see that are highly regulated. They are not going to be approved. But insurance companies, they have a severe problem, because not only the product has to be approved. So when we buy insurance, the price has to be approved by the national usually it's the national regulator. But also the company has to be certified as a solvent company. In European countries, for instance, we have a directive called solvency, and a company cannot operate unless there is a solvency standard for that company, because of course consumers have to rely on the company and buy the product and know that they will get compensated if there is an accident. Okay, so things we do, predictive modeling has to be compatible with current regulation. Okay, so if insurance is a regulated sector, black box models can be used internally in the company to predict risk, but they cannot be used externally to produce a price for consumers. And that's really a crucial point to understand. Insurance companies now are eager to use machine learning to improve risk measurement, but they want to do it internally to know exactly what type of clients they have and to analyze their portfolios. But they know they cannot use the predictions from those complicated or even black box models, because they cannot produce a price from those models. They have to show very clearly what is the weight of each variable in the final prediction. There are problems to fill the gap between the risk and the price because of the methods that are restricted for price calculation. But I also wanted to introduce this to you today, because I know there are many data scientists in the audience, and I wanted to explain why insurance companies are interested in data sciences nowadays. And it's because of the enormous amount of information that they are gathering every day. Okay, let me go to the third question I wanted to address today. And in this one, I must say, this is ongoing research. This is really what we are doing right now. I just wanted to give you a few examples of what we call risk analytics. So looking at the data and trying to get information. one of the nicest things that we have done is percentile charts. And let me show you very briefly an example. But before doing that, the summary for this part is as follows. There's nothing in the market like this. Companies are not going to use risk analytics today because this is still too premature. But the innovation we are working on right now is we are working on giving feedback to the drivers. So not only the price matters, but also safety matters. So if we detect that the driver is having a dangerous behavior or changing the way he or she is driving, we should be able to warn the driver. And this really is a different use of the telematics data. It's a use to promote safe driving. And the tools that we are using is quantile regression, essentially, and reference curves. The example I was referring to is this one. That's a prototype. What you can see here on the horizontal axis is the total kilometers driven, and the dot here represents one driver. And you can locate that driver in a percentile chart and see, okay, this driver is really, you know, like the child's growth chart. He's in the upper quintile, meaning that he's a little bit away from the average. And if I represent here one measure, here I'm representing the kilometers driven above the speed limit. It means this person is driving maybe too many kilometers above the speed limit. So with this, I can identify risky driving. And what I'm doing here with this shiny application is, well, I can change, okay, the percent of night driving. I can change the gender. I can change the age of the driver. And this has been done with real data. And I can really track the evolution of this driver and see if the driver goes down to you know, an average excess of speed. There are always excess of speed. I mean, very few drivers have no excess speed because there's always a situation where people want to drive a little bit faster. Another thing that we are currently doing is this driver monitoring that I'm showing you here. And here you can see we have dates instead of distance. So we are following someone from January 2018 to January 2019. And you can see the evolution is the distance driven. And you can see there are blank spaces where the car was not used during holidays or maybe here. And you can see here, well, that's in Spanish, but it means that the windows were broken and the car had some problem on the road. And so we can really locate the accidents. There seems to be no relationship here. And also here we look at the kilometers, the percentage of kilometers above the speed limit in urban areas. And what we see here, okay, the two accidents do not seem to be much related to the behavior, but there is a change of behavior here. So suddenly this person has a little bit, a tendency to have too much speed in urban areas during this period of time, And that's really something to warn the driver about, because something is telling us this person is driving too fast, and maybe it's driving in another zone or has to do something faster. I don't know. But we are detecting this, and now we are working on how to give this information back to the driver. Okay. I just want to skip to the last part of my talk. Very briefly, there is a slide where I'm just trying to show you the complexity of insurance data. I can come back to these slides if there are questions about this. The center of insurance companies is always customers, but they have a lot of different sub-databases depending on the different products, and those products generate claims. Claims are accidents that have to be paid. There are also these concerns about reserves. I mean, if there has been an accident, but maybe there's going to be a legal procedure until the accident is being paid. You have to reserve money. There is this solvency capital standard because the company has to stay solvent. So that there must be money to pay those claims. And there are all kinds of new things coming up, like social media information about the customers. There is also mediation and distributions that coming in, services that are provided. And also all these files have longitudinal information. And on top of this, we are nowadays getting all these streams of telematics data. I can go back if you have more questions about that. So the conclusions for what I wanted to tell you today is, what have we learned? Three things I wanted to communicate today. The first one is that The statistics on the driving style are much more informative than the traditional factors. And many of us, we do have a traditional insurance. Those rating factors are, well, our age, our zone, the type of car. But if you introduce this information about style coming from telematics data, we get much more informative, and predictive modeling becomes much richer. The level of personalization in insurance has changed a lot. There is also a huge debate about that, because insurance is usually about solidarity between people, and we cannot really make people very risky people pay a lot and non-risky people pay zero. So there's also this solidarity issue about personalization. And insurance is going to be reinvented in the future. That's my guess. Actually, before this webinar, there was another webinar that I couldn't attend until the end because we had to start ours. But there were insurers talking about how insurance is going to be reinvented because of all this digital revolution, yeah? And also because it's aimed at protecting people and preventing accidents, and people, we will pay to prevent accidents, not to compensate accidents when they have occurred. So what comes ahead is, okay, a lot of research about relevant summaries of the data, how to present insurance as a utility and not only a compensation. A utility, I mean, the electricity bill works like this. We pay a flat rate, and there is something coming out depending on when we are using electricity in our house. Then we will see also insurance pools, you know. That's a different concept that I can go back if you're interested. But we can see joint ventures between insurers and manufacturers, because the devices can be already built up in the car inside when the car is being in the factory. So they come already with all these data collection devices. I want to thank some of the data source provided. All the data that you have seen today, they are real. They come from real companies. One of them is Mapfre, another one is Emergent. And I also want to show you a list of papers that I can send you a copy if you are interested, and also of working papers that we are doing today. Thank you. This is the end of my talk. I really am happy to be able to answer if you have questions.